Are you able to get the figures for Citizen?
Zero point
443. 443. Uh-huh.
0.557.
0.557. If you add that, you should get one. Correct. So you can say the Citizen market share is 42.3%, and the market share for Mira is 55.7. So you see, whoever is doing the distribution, if for instance the same newspapers are coming from the one publisher, or let's say you are a vendor and you are selling the two newspapers, you'd be able to know if I do tomorrow Citizen 44.3 and I do Mira 55.7, then it will be easier to plan or to get the probability for the subsequent day. If you look at the part B of the question you've been asked, or you've been asked for a steady state. If the process persists long enough, what are the eventual readership levels? So you see, if Citizen and Mira are able to run these for a duration of time, let's say 1 year, 2 years, 3 years, if they've been in the market and the marketing department are doing a certain survey, they should be, and that's why we do the Markov for purposes of marketing. If all the Markov process conditions hold and the transitions go on sufficiently long enough, we should get a steady state, or what we are calling the dynamic equilibrium state. We should get a dynamic equilibrium state where we will not be running this day in, day out. We'll be having our steady state, and it should be steady, and it will be used now to guide the process. Now, this depends on the transition matrix. Don't know whether I'm sharing the. This depends on the transition matrix. For instance, our transition matrix here is 0.5, 0.4, 0.6. I've said we are guided by the stochastic equivalent, where we say P plus Q is equal to 1.
Excuse me.
Yes? Yes, you're excused. How do we assist you, Charity?
Your voice is breaking. Your voice is breaking.
For everyone? Is it the case for everyone?
On my side, it's
You're okay.
So check your network. You see, we are running on a network. At times, it could be your end. Charity. Okay, I come again. I'm saying we've been here asked for a steady state of readership of these two distributions, Citizen and Mira. So to get that dynamic equilibrium, it depends on the transition matrix. And we've said, we've put it such that our P plus Q will always give us 1. And to solve our problems, we want to work with the P's only. So I want us to work in a manner that if we say, let me see. So this, we are getting steady state. Steady state. You'll find some others using dynamic equilibrium, but steady state is common. So we are working on a situation where our initial condition, which is PQ, If we multiply it by our transition matrix, we'll be able to get that steady state. You get? So this is the PQ. The PQ that we resort will be our long-term readership for citizen, and so our P will be representing citizen and our Q will be representing mirror. We are doing that to avoid losing what we are looking for. So the steady state will be such that our PQ, or the original or the initial condition multiplied by the transition matrix, will be giving us this. Now we don't have the initial, and this is what we are looking for, or this is the steady state that we are looking for. So we can say, let us work with what we have. So P, Q. We have that. Then I have this, the transition matrix is here. So this one I can just put it and paste it here, somewhere here. And bring this closer. I should get P, Q. Let me make things a bit elaborate here. So it should be 1 minus P. So I want you to understand this part here. My 1 minus P is Q. Because we said P plus Q is equal to 1. So if I take my P on the other side, my Q will be 1 minus P. The reason why I'm presenting this way is for purposes of easier working. So going forward, I'll be using P and 1 minus P to represent my PQ. So I can come here and replace. So I hope we understood. I'm replacing my PQ with P and 1 minus P. So 1 minus P is my Q. So that I can open now the equations and solve. So let me multiply. So I'll get P multiplied by 0.5 will be 0.5 P, right? Then I add 1 minus P multiplied by 0.4. I'll get 0.4 into 1 minus P, right? So this is my P. It is representing my P here. All P. Undo. So are we there? So I can solve for P. So I'll open and then collect the like terms. So 0.5 P plus 0.4, I'm opening, plus.
Plus or minus?
Not plus, minus 0.4 P. That will give me P, correct?
Mm-hmm.
So my 0.4 P, this minus 0.4 P, and I have a 0.5 P. If I subtract, I'm going to be left with 0.1 P plus 0.4 is equal to P, right?
Mm.
Then I can now collect the like terms together and say 0.4 is equal to P Now my P will cross the is equal sign minus 0.1 P, right?
Yes.
So I can come here and say P will be equal to 0.4 divided by 0.9, isn't it?
Yes.
What do you get?
0.44.
0.44. So we are getting 0.44. Remember that was representing our citizen. So that is 44% or 0.44. So with that, we can get mirror, isn't it? Because mirror is equals to 1 minus P. And because you've gotten P as 0.44, what will be our mirror? It will be 0.56, isn't it?
Yeah.
So our steady state will be, so this is what will be the steady state or the dynamic equilibrium for the readership. 0.44, 0.56. So this particular seller will not be calculating the readership probability every day. We've gotten or we've been able to calculate the steady state. And that is the work of Markov to help get the steady state. Of course, I said is a probabilistic approach, and that is why that's why we are talking of P plus Q is equals to 1. Look at the next example in the bottom. You have into the manufacturer of Tamu soft drink has been facing stiff competition on its main brand, Tamu Cola soda. The management is considering an extensive advertising and rebranding campaign for Tamu Cola soda. If the current branding remains, the transition matrix of the consumers between Tamu Cola and other brands will be as follows. So you have our transition matrix. And then after advertising and rebranding campaign, the transition matrix is expected to change as follows. It has changed. And then you've been asked, the advertising and rebranding campaign is expected to cost 20 million each year. There are 40 million consumers of soft drink in the market, and for each consumer, the average profitability is 5 shillings annually. So for each drink that you buy, there is a profit of 5 bob annually. Required the equilibrium state proportion of consumers using Tamu Cola. And you've been told to give it before the advertisement and after the advertisement. Where do we start? We need the initial condition. What is our initial condition? Being asked of the equilibrium state proportion of consumers using Tamu Cola before the advertising campaign. And this is the initial, isn't it? The 0.85. This is our transition matrix, 0.85, 0.15. You can get it. In other words, we are looking for a steady state. So we are talking of P. Start with this. So we are talking of P. Q. Then we've been given our matrix is 0.85 and 0.25. The second one is
0.15, 0.75.
The second one is 0.15.
Yes. 0.75.
0.75. So this is our transition matrix, the T. So this will be giving us now the equilibrium state before the advertising campaign, right? So we go the same way. We know that this can present this as P and this as 1 minus P. Always remember to convert them because whatever we are getting now is PQ. So you can get it, we can go on. So that will be 0.85 P plus 1, no, plus 0.15 into 1 minus P. And this will give us P equals to P. So we open up is 0.85 P plus 0.15 minus 0.15 P is equals to P. So this is 0.15, this is 0.85, right?
Yes.
We are going to get
0.7.
0.7 to 0.7 P is equals to 0.7 P plus 0.15 equals to P. So can we be able to get our P at this point? What will be P? What will be P? 0.3 divided by 0.15, isn't it? How do you get? Is it 0.15 or it is 0.25?
25.
We are working with the wrong. Somebody say 0.15. That's okay, we can change. No big deal. It is that way. So what will change? 0.85 minus 0.25. 0.6. So this will be 0.4, isn't it? Is it?
Yes.
And this will be 0.25. What do you get?
1.6.
1.6.
Yes.
0.4 divided by 0.25. In probability, we are not supposed to get if you get more than one, we are wrong. Either we are wrong or the question is wrong. One of us is wrong.
I'm getting the same.
It is
0.25 divided by 0.4.
or it is 0.25 divided by 0.4. What do you get?
Why is it not
0.6.
We are
I have
getting
a
the value.
question.
Ask.
When you get the 0.7 plus 0.25 is equals to P, so see the 0. It's going to be P minus 0.7. I'm getting 0.3. Why are you getting 0.4?
Yeah, 0.3.
Yeah.
Not 0.3. It's supposed to be 0.6.
0.6.
Supposed to be 0.6. We change 0.25. So
Okay.
0.25, 0.85 minus 0.25 is supposed to give us 0.6. So if we take it on the other side, it will be 0.4.
Okay.
Isn't it?
Yes.
I think that's okay. So what's the answer? What's our value?
0.625.
25. So the other one, the Q. The Q will be the difference. 1 minus 0.6 something. Should be 0.3375.
0.375.
So this will be our equilibrium state before the advertising campaign, right? Then the next part we've been asked, the second part, after advertising campaign, and you've been given also the transition matrix for after advertising campaign. Again, we go through the same process. So this time we'll be talking of P, and read those things well so that we don't repeat again. It is 0 point. Give me the transition matrix. Is 0.9, 0.1.
Yes. 0.3.
0.3.
0.7.
0.7. We go on. So this will be 0.9 P plus 0.3 minus 0.3 P equals to P. give me the value of P. Zero point 0.4. So it will be 0.3 over 0.4, right? Over 0.4.
Zero point 0.75.
0.75. So the other part will be 0.25, make a 1. So that will be our equilibrium state after advertisement. And then the second part of the question, the part B, been told the expected annual profit increase or decrease after advertising campaign. The expected annual decrease, increase or decrease after the advertising campaign. We've gotten our quotient, so it's now easier. We've been told this information, the advertising and rebranding campaign is expected to cost 20 million each year. There are 40 million consumers of soft drink in the market, and for each consumer, the average profitability is 5 shillings annually, right? We are looking for Tamukola, isn't it? Not the others, Tamukola. Because our answer is in, the question is not comprehensive. So this is Tamukola. We'll be taking this as Tamukola. Then the other one is others. So that we look at the profit. Go back. So that we look at the profitability of Tamukola. So Tamukola, the first one will be 0.625. We are multiplying by 40 million, the consumers. Multiply by 40 million. Then you multiply by 5 shillings. We are making a profit of 5 for every drink that is consumed. So what will be the profit before advertising? You want to see whether the advertisement is assisting us ama ni pesa tu tunatumia. What are you getting? $0.625 multiply by 40 million multiply by 5. What are you getting?
125 million.
125 million. I've just written a name. Then we go to the second one. We've been told after the advertisement, our Tamukola is 0.75. So I multiply by 40 million. Again, I multiply by 5. How do you get? If it is an upper figure, is working. If it is not, we recommend the manager to scrap off the advertising budget.
150 million.
You are getting
150 million.
150.
Yes.
Confirmed?
Yes.
You can see the advertising is working. We are able to garner 25 million. Before the advertisement, we are getting a profit of 125. So this is how Markov is used. It will help the business firm make a decision on whether to undertake or to forfeit the opportunity cost or the alternative next best. So we would advise or recommend the advertising campaign to go on. We have the other question there. In total, a university's service department is considering leasing one of two possible computers. A computer can be found in operating condition O or non-operating condition NO. The daily transition matrix of the two computers under identical maintenance is as follows. We got the computer A and we have the computer B. And then we've been told which computer should the university lease if the leasing charges are the same. If the leasing charges are the same. Where do we start? Into the leasing charges are the same. This is what you are doing. We'll just take our PQ and this will be our matrix. And then we'll take the next one and compare. We can do that. We are saying PQ or P, 1 minus P. Give me that, give me the matrix for O, computer A. What's the matrix? Now we open the question. For computer it is 0.95, 0.05, 0.95, 0.05. Then for computer B, 0.9, 0.1, 0.1. Then for the second one, for the NO or computer B, you have 0.98, 0.02, and then we have 0.85 and 0.15. So this is it. We form again the equation and we get the P and then get the Q. Of course, we are interested in our P. So our decision criteria will be the computer that will use most or that will be operational most of the time. That is what that will prevail. It shows that the other one is running redundant, isn't it? And that will be our decision criteria. I want you to do the two. Whatever you are going to, for instance, if you are able to get, let's say, this one 67%, and this one we are able to get, let's say, 94%, then we'll advise the university that computer B will be operational most of the time, and therefore it is the best to lease. You get? So a decision criteria will be reached on which computer has the highest operational time, because we are hedging our decision against time. We'll try that. Then the fourth one, been told Habib Food Liner, Ngugi Supermarket and Quick Stop Shop Groceries are the only 3 grocery stores in Sandtown, a small town in northern Kenya. A market research involving shoppers over a 10-week period indicated that Habib retains 85% of its shoppers, while 10% and 5% shift to Ngugi and Quick Shop respectively. each subsequent week. Goges lose 20% to Habib and 5% to Quick Stop. Of those who shop in Quick Stop, 15% and 10% shift to Habib and Goges respectively. The total grocery store customers in Sandtown are estimated at 10,000. Each shopper generates revenue of about 500 per week. What are the projected weekly revenue for each grocery store at equilibrium? Again, we've been asked of the equilibrium state. How do we start? How do we start? Guys, we've done several of these things. What I'll do, I'll take these two questions in the discussion forum. We try to respond, then I'll share the answers after people have tried to respond, so that you practice with them. Is that okay? Do you have any question? You can respond before the end of the class. The class is supposed to end at 8. Any question? If you are keen, don't know what you're seeing on your end. I want to share the photo. I want to share the, let's see my screen. I want to share the photo. You can see my photo.
Yes.